Yes, we're going to talk about a different way to accumulate snow. Not by producing it, by collecting it by the wind. So it seems like a really easy and cheap way to get snow. So let's see what we have found out in this way. What we know is that a lot of snow fences were used back in the days for securing roads and railroads from not getting all the drifting snow covering the whole roads. So it's an old technique and it's been used for a long time, but how well is this used for collecting snow among ski areas? And we would like to see can we improve this technology for just collecting snow and so on? And what we know is it should be really useful for ski areas that are wind exposed or high alpine places where maybe you can't produce snow either because it's so far away from a water and electricity source. For example, long cross-country ski trails, it's ideal for this solution if you have places where you have very little natural snow. So what we did was we went on a study trip to see how are ski areas using this, because they are actually ski areas using this technique. And what we found out was they were not having any really thoughts of how they were building it or designing it. They were more just testing by experience a little bit, and this works okay, and they just keep building the same snow fence over and over again. And we were thinking there's a little bit of knowledge gap here we need to fill. So we went back and with an idea how can we design the ultimate snow fence for collecting snow for ski areas. And this process, Sondre gonna tell a little bit more about.
Okay. Yeah, after the study trip, we went to the wind tunnel at NTNU, but first we did an evaluation of different design based on buildability, stability, appearance, portability and cost. And after that we went to the wind tunnel. Yes, I can trykke her. As you can see here, it is a small scale model, I think 1/10 of the full scale model of 1.6 meter. You can see the turbulence behind here, which makes the wind speed reduction, which makes the snow after the fence accumulate in a big pile behind here. As you can see, we couldn't use any particles in the wind tunnel, so we had to measure only the wind speed reduction, and afterwards we tried to relate this to the reduction in accumulation of snow. Yeah, here you can see two of the small-scale models who tested the best. This graph shows the vertical displacement, and the different colors here are different measurements behind the fence. So this one here is 1.5 height of the fence behind the fence, and so on further behind. And this dotted line here is the reference wind speed in front of the fence, and you can see on the top of the fence the wind speed is increased, and when it is on the left side it shows a reduction. So you can see here close to the fence you have a large reduction or turbulence behind the fence, and as you go further back this reduction shrinks, and you can see the 40 porosity the fence here, we saw the largest reduction in wind speed. Yeah. the literatures that we read, it stated that a 50% porous fence could accumulate the most snow during the season, but this is only when the snow is not removed. So our hypothesis is that if you have a less porous fence or a more closed fence, you will have a better trapping efficiency if the snow is removed during the season. And this picture shows how a fully trapped or closed fence will accumulate snow like a profile like this, and 50%, you can see here with the black line, will accumulate the most amount of snow during one season.
Yes, and now we're moving out from the wind tunnel in Trondheim to actually full-scale testing in Vålådalen, about 100 kilometers away from Östersund here. So here we were building up the 50% porosity, so half open, half closed, or the 40%, so it's a bit more closed. And then Vålådalen were using already snow fences, so we tried and tested there against the two prototypes we decided come out as the best ones from the wind tunnel experiments. And we also put some measuring sticks in different distances after the snow fences, so we could read how much snow is collecting at different distance after the snow fences. And here you see a picture. You can actually see some of the snow is collected behind the snow fences. And you can see the different on this graph. So we have the blue line here is showing the one that Vålådalen was using, which is 7% closed or 30% porosity. What it shows, it's collecting the most snow at a distance very close to the fence. And this is this one. So you can see it has quite a big top here. But as further away from the fence you go, it has less snow than the orange and the gray line here, which is the orange is the 40% porosity and the gray is the 50. And the 40 is following the same, so you're collecting more snow than the 50 close to the fence, but not as much as the 30% porosity. But it also has less snow further away. So if you look at the total volumes here, we measured that the 30%, the Vålådalen design, collected 30.6 cubic meters, and the 40% collected 37.8 cubic meters, and the 50% 41.2 cubic meters. And this is, we could collect more if it will be snowing more, of course. So we still keep running this test the whole winter to see the results. But this is so far what has happened. And it's kind of interesting to see that what you see here is you collect most with the 50%, but if you would like to have the snow closer to the fence, you could use a higher degree of coverness, so a lower porosity. And based on these results, actually we were consulted by the Meråker and Storlien, the ski competition there. And Søndre went on a trip there to implement, so he can tell about his experience there.
Yeah, I think it was two weeks ago now. I was on a trip on the mountain here in almost at Storlien, and here you can see it's not so easy to see, but the competition on Thursday, which goes from Storlien to Meråker, will come over here, and the ski tracks goes this way. I can show next slide here with video. You can see some areas here is very little snow, and they wanted to implement these fences to get some snow deposits in these areas. And the biggest problem they had was that there was very little snow in this area, so they had to move the snow over a long distance to cover this this area. So yeah. And in the end, we want to just talk a little bit about considerations when building these fences. The most important thing is to place it against the dominant wind direction, but you can have an angle of 25 degrees, which works quite well. The second thing is the distance from the track. You need to remember that snow accumulation can get 20 times the height of the fence, so it's quite long. It's not a problem when you have when the snow parallel to the ski track, but if the wind comes this way, you have to have the accumulating snow over the ski track, so you need to have this in mind. Also, the bottom gap of the fence should be 10 to 15% of the total height. If it's not, you can get accumulation of snow in front of the fence, and this will reduce the effectiveness of the fence. And the height of the fence also depends on the use. Of course, a higher fence will trap more snow, but you will need a stronger fixation to withstand strong wind loads. And yeah, we haven't got an answer on our hypothesis yet, but we think a 40 to 50 porosity seems to be the ideal coverage. But you also need to consider, if you want a lower porosity, the snow will accumulate in closer to the fence, and this can be ideal for some situations, of course. So yeah. Yes, thank you.